Okay, the second vocab for this lesson is simplest form. So when we talk about simplest form, we are wanting to combine parts of the fraction so that we have the least number of pieces. So if I were to shade in this fraction, like this, the way that I would name it, or how I would call it, is I have 4 pieces shaded out of 8 total possible pieces. So it's going to be 4 out of 8. Now if I wanted to write this in simplest form and I want the least number of pieces, I'm going to see if I can combine the pieces equally to make larger pieces out of this fraction. So what I can do is, let's see, 8 is an even number, so I know 2 is usually going to work. So if I group every 2 pieces together to make a larger piece, I could represent it by making a darker line. So there will be a grouping of 2, another grouping of 2, another grouping of 2. And if I shade it in to show the new grouping, it would be like this. So here's now a larger piece, and here's the larger piece, and then there's a larger piece and a larger piece. I didn't change the value, I didn't change how much is shaded, I just changed the size of the piece. So now if I were to look at this fraction, here are the 4 larger pieces, and how many are shaded? 2 out of the 4. This is equal or equivalent because the value didn't change. Now I just represent it by naming it 2 out of 4. If I wanted to combine it even more and just make one line down the middle and combine all of this side and all of this side, it would then be equivalent to 1 over 2. But we'll leave it like this for now. When you do this mathematically without the model, you're going to think to yourself, the same as before, well, if I have 4 eighths and I know it's equal to 2/4 or equivalent, I want to ask myself, well, how did I get from 8 to 4? I divided by 2. And we know that when we are doing equivalent fractions, the numerator and the denominator need to be the same because we're not changing the value, we're just dividing it by 1. And that's kind of hard to grasp sometimes, because by dividing a fraction, we're actually making larger pieces. So that's just an interesting thing about fractions. Let's do another example. So if you wanted to simplify basically any fraction, you're going to use division. So let's say we can continue this. Let's say I want to make this even more simplified because I can. I want to think to myself, and here's the second way you can write it, like before. I'm going to divide by something in the numerator that is the same in the denominator. So I ask myself, what can I divide 2 by that I can also divide 4 by? Well, I can divide both of them by 2. So if I show it like this, 2 divided by 2 is 1, and 4 divided by 2 is 2. So my simplest form is going to be 1/2, and I cannot reduce that anymore. Okay, so I'll try a few more examples. Let's make 8 over 12 in simplest form. So what you want to think of is, what is the greatest factor that I can divide the numerator and the denominator by that is the same? So let me start with 8. I can divide 8 by 8, but 12 is not divisible by 8, so that won't work. I could divide 8 by 4. Can I divide 12 by 4? Yes, so I can use that. So I'm going to show my work. Eventually you don't have to write this step, you will do it in your head, but for now you want to make it very organized to show your thought process. So 8 divided by 4 is 2, 12 divided by 4 is 3, and there is nothing else I can divide this by. I can't divide 2 by something that I can also divide 3 by, so that is your simplest form. If I had something like 18 over 30, again, I want to think, what can I divide the numerator by that I could also divide the denominator by? Okay. So I'll start with 18. Can I divide 30 by 18? No. What's the next factor of 18? 9. Can I divide 30 by 9? No. What is the next factor of 18? 6. Can I divide 30 by 6? Yeah, so 6 will work. So I will divide the numerator and the denominator by 6. 18 divided by 6 is 3. And 30 divided by 6 is 5. And I give it one last look. Can I divide 3 by anything else and also 5? No, so that is my simplest form. You can also use simplest form when you want to compare two fractions and see if they are equivalent or not. So let's say we have 6 over 8, and I want to know, is it equivalent or not equivalent to 9 over 12, 9/12. Okay. So since you can't easily go from one number to another, I can't easily say, well, how did I get from 8 to 12? Or how did I get from 6 to 9? That's not going to work to help me compare them. So what I can do is take them both down to their simplest form and then compare the simplest form. So I start over here, or either way, and I'm going to divide them. Let's see, let me start with 9. Can 12 be divided by 9? Nope. Can it be divided by 3? Yes, so that's what I will use. 9 divided by 3 is 3. 12 divided by 3 is 4. So the simplest form over here is 3/4. Then I do the same thing on this side. I'll just do the arrow method on this side. You can choose either one. Eventually you'll cut that out. So what can I divide them both by? 2 I know for sure. But is there anything bigger, like 6? No. 3 works for 6, but 8 can't be divided by 3. So looks like 2 is going to be the factor. So I will divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Oh, look at that. 3/4. So it turns out that it might not look like it at first, but these two fractions are in fact equivalent. Let's do one last one, and you can pause and try it out on your own and then come back and watch the rest. Or if you don't need any more practice, that's great. You can move on ahead. But we'll do one more. So let's compare 3/12. And I want to see, is it equal to or equivalent or not equivalent to 2/4. Okay. And sometimes you can tell right away, like once you get used to this, you'll be able to almost just by looking at it know if they are or not, but we'll show the work anyway. So 2 and 4, what can I divide both of those by? They can both be divided by 2, and I'll get 1/2 on this side. What can I divide 3 by that I can also divide 12 by? Well, they can both be divided by 3. So on this side, I will get 1/4. So the simplest form over here is 1/4. Simplest form on this side is 1/2. Are they equivalent? They are not equivalent.